about this for a second. Those tiny earbuds you might have in your ears right now, they're basically tiny supercomputers, and their main job isn't even to play music. It's to perform thousands of calculations every single second to actively create silence.
It sounds completely backwards, doesn't it? How on earth do you make things quieter by adding more sound? Well, that's the central paradox we're going to solve today. Stick with me because the answer is this amazing mix of pure physics and some seriously clever engineering. And you know, before this tech ever made our daily commute more peaceful, it had a much more high-stakes job. It was born in the cockpit of a jet, designed to help pilots hear critical communications over the deafening roar of the engines. That's right, your earbuds are basically descendants of top-tier aviation tech. So, let's get into it. What feels like straight-up magic is really a fundamental law of physics. We're about to break down how it's possible to literally erase a sound wave before it even has a chance to hit your eardrum. First, a super quick refresher. What even is sound? It's not really a thing, it's an event. It's just a pressure wave, a vibration rippling through the air. When those vibrations hit your eardrum, your brain is the one that does all the work, translating them into what we perceive as sound. Here's the core idea, the secret sauce. Imagine that wave on the left is the annoying drone of an airplane engine. To cancel it, the technology needs to create its perfect opposite, its evil twin, an inverse wave, or anti-sound. See how it's a perfect mirror image just flipped upside down? Every peak has a matching valley. So here's the magic moment. When you play both of those waves at the exact same time, they collide. The up from one wave perfectly cancels out the down from the other. The result? They completely annihilate each other, leaving you with a flat line. Silence. This beautiful piece of physics has a name: destructive interference. Okay, that's the theory, but how do you actually shrink all that physics down into a tiny, sophisticated machine that fits inside your ear? Let's move from the what to the how. This whole thing happens faster than you can blink. First, a tiny microphone on the outside of the earbud listens to the world around you. A processor inside instantly analyzes that sound, generates the perfect anti-sound wave we just talked about, and then plays it through the speaker. The original noise and the brand new anti-noise meet and destroy each other right there in your ear canal. And the speed required here is just mind-boggling. To create that perfect anti-sound, the tiny chip in your earbud has to listen or sample the outside world more than 10,000 times every single second. That's a constant stream of incredibly complex math happening in a device that weighs almost nothing. And like we said, this all started on a flight. Back in the 70s, Armor Bose was trying to listen to music, and the engine noise was just ruining it. That one moment of frustration led to decades of research. Finally, in 1989, the first commercial noise-canceling headset was released. Not for music fans, for pilots who desperately needed that clarity. But as anyone who's used them knows, it's not a perfect cone of silence, right? So let's talk about why some sounds always seem to sneak through, why you can still hear that sudden shout or, yes, the baby crying on the plane. It really comes down to this: predictable versus unpredictable noise. The system is an absolute genius at canceling constant, low-frequency sounds. That steady drone of an engine is easy to predict and erase. But sudden, sharp, high-frequency sounds like human speech, they change too quickly. The processor just can't generate a perfect anti-sound wave in time, so parts of it get through. Now, not all noise cancellation is created equal. There are a few different ways to do it. The simplest is feed-forward, with a mic on the outside. It's fast, but it's kind of guessing what you'll hear. Then there's feedback, which puts a mic inside the earbud. It's way more accurate, but it's always reacting a split second late. And then you have the gold standard, hybrid. It uses both. One mic on the outside, one on the inside. It's the best of both worlds, anticipating the sound and then double-checking its work for the most precise cancellation you can get. And if this technology has one mortal enemy, one kryptonite, it's wind. When wind rushes over that tiny external microphone, it creates this chaotic rumble that the system totally misinterprets as sound. It then tries to cancel this noise, but that often just creates even more weird distortion. It's a huge challenge for engineers. Okay, enough about the tech. Let's talk about you and your brain. Because creating this bubble of artificial quiet has a really profound effect on us psychologically. This is all about the neuroscience of silence. Your brain is working all the time to filter out background noise. That takes a lot of energy. It's called cognitive load, and it even raises your stress hormones. By just removing that constant drone, you're literally giving your brain a vacation. This helps you focus better, sure, but it also tells your brain you're in a safe space, which can make you feel calmer and way less tired. So, have you ever felt that weird pressure sensation when you first turn on noise cancellation? Well, it's not actually real pressure. It's just your brain getting confused. It's so used to hearing constant low-level noise that when it suddenly vanishes, your brain doesn't know what to do and misinterprets that absence as a change in pressure. It's a fascinating little illusion. What's really clever is that the very same hardware can pull off the exact opposite trick. They call it transparency mode. It just flips the script, using the same microphones to intelligently pipe the outside world in, making it feel like you're not wearing anything at all. It's the same tech, just running in reverse. So, where does this all go from here? We're on the edge of some truly science fiction level stuff, moving beyond just simple on or off cancellation into what you could call intelligent sound management. The next wave is all about AI. Imagine earbuds that know you're walking on a busy street and automatically let in traffic sounds for safety, but still block the wind noise. Or that can identify a specific conversation and let you hear it clearly while still canceling everything else around you. We're moving towards a future of completely personalized adaptive audio. So let's circle all the way back to where we started. The most mind-bending truth of all is that your earbuds aren't taking sound away. They're actively adding a very specific, perfectly engineered sound in order to manufacture a pocket of silence just for you. And that really leaves us with a final thought. As this technology gets more powerful and more intelligent, the real revolution isn't just about the quality of the music we hear. It's about gaining the power to curate our own reality, to decide moment by moment which parts of the world we let in and which parts we choose to leave out.